security can't solve crucial problems when they have to wade through thousands of alerts a day. With ServiceNow, you can easily prioritize and respond to your most crucial business threats. That way you can go from overwhelmed to under control. ServiceNow brings security, risk, and IT together on one platform. Learn more at securityweekly.com/ServiceNow. When it comes to modernizing identity, Active Directory just makes everything harder. From managing access for contractors and departing employees to securing cloud apps and on-prem systems, your company deserves better. Choose Okta, the modern identity platform that securely connects anyone that touches your organization to any technology they want to use. Okta reduces AD vulnerabilities, secures not only employees but contractors and customers, simplifies domain consolidation, and reduces your attack surface. To learn more, visit securityweekly.com/Okta. Welcome back, everyone, to Enterprise Security Weekly. Our next webcast is February 13th with Sri Sundaralingam. We will be talking about capturing packets from the cloud. That's right. We all know the network does not lie. And if your organization is deploying apps to the cloud, as we just talked about, it's an ever-increasing trend. You may be sitting there going, wait, how do I get my packets?
Right.
If you're wondering that, you should attend this webcast, as we'll be talking about it and showing a demo.
And it's not only packets in the cloud, it's packets in the cloud and on your network in these hybrid environments, and being able to understand what's going on between them. So I think this will be really interesting.
If you go to our website, securityweekly.com, you can go to the webcast drop-down menu and register for that.
Yes.
Sweet. In this segment, we're going to talk about primarily containers and migrating some legacy applications, which is interesting. You may have different types of legacy applications. You may have ones that were written in-house. You may have larger applications that have multiple components, some of which were written so long ago that you maybe probably shouldn't even bother trying to get those in containers, to be quite honest. But you may have other apps, again, that are either open source or like I think WordPress, MediaWiki.
Yeah.
I was looking at Mattermost as another one. So you may be using some of these open source applications, and there's good use cases to use these in enterprises. The problem that I found is the microservice deployment, creation and deployment of these open source applications is really, really bad. Like, they're not packaged for a modern deployment, even into sometimes local instances don't take into account, like, you're going to have multiple iterations. So I like to treat applications that maybe, you're not necessarily developing a lot of code for, but you're just taking and customizing an open source app. I treat those like any other application. And I want to be able to deploy those, configure and deploy them the way I would, a React application that we wrote to support our business, right? Or a Python application. I like to treat them the same way. I think there's huge benefits. This is really speaking to not just infrastructure as code, but ops taking advantage of a lot of the development tools to manage the infrastructure and operations for your business. Because it's nothing new. You're not going to learn about any like brand spanking new thing here. This is kind of like an in the trenches kind of discovery of just getting started. Taking a somewhat legacy or application that's not in that deployment, right, to just basically ease your headache of managing and maintaining it. Right.
So I think it's important why we chose this one and why we looked at it. We haven't touched our MediaWiki in a while, and we use the wiki for our show notes.
Yep.
And we're like, wait, we haven't updated that in a while, right?
Yeah.
And so when you look at it, you're like, oh, well, I can update it and manage it like the old-fashioned way, or can I actually do this through the automation stuff that we set up for our other application, right? And so your kind of project was, how do I get MediaWiki over into an environment where we can be a little more consistent with updates and upgrades and et cetera as part of that. And you learned some very interesting things trying to
very interesting things. Going along, the internet has bad advice about a lot of things. If we take a look at this Docker file, and there should not be, it's actually in a different directory, there should not be any passwords in here, which is obviously on purpose, right? And the internet just has some really bad advice, even we just start like right here, right, with your base Docker file, right? So the first thing you need to do is you need to look at your application, whatever that happens to be. This just happened to be MediaWiki, which needs a web server like Nginx, the application server, I use that term very loosely, like PHP, right? And PHP still powers a lot of these open source applications you might be using, although that could be anything, and it has a database component. What's interesting is if you go out online and you start copying other people's projects, it's not going to be what you need. And they're nowhere near production ready for what Matt and I were just talking about. So you need to really back up and think about your strategy. And really what I realized very early on was I can't use anything that's like available and off the shelf. So like I can't just pull images from Docker Hub. I can't just pull someone else's.
You can't just do a pull request and throw the container in Kubernetes and spin it up and let it go?
No, because it's not going to be configured for how you want to deploy it. As you've probably seen, there are many, many ways to deploy an application, right? You can go the legacy route. You can spin up some instances, maybe directly in EC2 or in DigitalOcean or Linode or Azure, whatever it is, right? Install everything all on one system. Maybe you've got another system that's a database, or you're doing it all in one. And that's a strategy. The problem is when you update that, it's going to be a nightmare and it's not very maintainable. So then you start thinking, I want to break it out into microservices. But your deployment's going to be different. You have different requirements in the ways that you want to do things. So you see the first line right here, because we talked about this in a previous segment, is I pull the base Debian image, right? And I build my applications on top of that. Now, as it turns out, this default instance of Debian Buster Slim, when I took this project and got it all the way up to building my images and deploying them into ECR, which is the Elastic Container Registry, you can enable auto scanning in the Elastic Container Registry. Actually, those instructions on how to do that was one of the easier parts of this whole process. Amazon will actually scan the images for you. We talk a lot about container scanning in companies that do it in open source projects. Turns out Amazon just baked it right in. I don't know what they're using for that, if they develop something on their own, but I got a whole big long list of CVEs in there. Hopefully I can show that after. But so even doing this, I still had some vulnerabilities that I'm still working through as to how I those exist in like the base Debian, and this is a slimmed down image. That's where they exist. To go beyond that, there's, and I forget what the command was. I was just reading it yesterday. There's like the base image that Debian uses to build Debian on top of that. So like you can go, it's like Inception, right? How many levels deep do you want to go inside your container images? For this purpose, I started with Buster Slim. Now, you see my MySQL host database and user password. So let's talk a little bit about how you manage your basically secrets, right? And so in this application, many applications, you've got a database password. I'm basically managing those with environment variables. There's lots of ways you can try and do this. So you can do environment variables. There's multiple ways to do your environment variables, right? There's your .env. There's a custom .env. You can set it in your IDE. But basically, they have to live somewhere. So what I've done is configure that in my .env file. Then at build time, I can actually show you my compose file. That's in this. So in here, you can say I also don't have the passwords, right? This is pulling it from my environment file. So this really hinges on making sure that Paul doesn't accidentally check his environment file into Git, because that's where your passwords live.
Right.
So what I try and do is make sure I have a solid Git ignore that's not pulling where my passwords are. If someone breaks into my system, they're going to be able to see the passwords there in clear text, right? It's one of the risks of doing it this way. What I've tried to do is just really separate it, just to make it hard for myself not to check those passwords in. So I read them into my compose file. This happens in memory. I pass them to my Docker file. And then in my Docker file, I pass those into my build. Now, it turns out when you configure MediaWiki like the standard way, there probably are better ways that I haven't looked at yet. You write that username and password directly into a local settings.php file. So basically, the Docker Compose pulls them into memory. I pass those along. When I build my container, I write them into the file. I can show you the code. If you want this code, I'll send it to you too. it writes it right into the file. Basically, that just helps me not accidentally expose it anywhere but in my local env file or in the ultimate destination inside the image.
So other approaches would be some sort of secrets vault.
Yeah, so then you look at Docker secrets. There's a couple of different ways to do Docker secrets. If you're not using Swarm, my advice is don't even bother. When I looked at that, it basically you got to write a file out, and then Docker secrets takes and puts the secret inside that file inside your container. Then your container has to read that file. Don't do that. Just use environment variables, because it's basically, in my assessment, the same risk profile.
But if you're using Swarm, there are some advantages with Docker Enterprise and using Swarm as your orchestrator. Yeah.
Swarm will allow you to use Docker secrets in such a way that it reads it like from a server. It's almost like a makeshift vault, basically, that's included with Swarm. If you want to use Swarm, but
everybody's going Kubernetes, but there are some Docker Enterprise users out there that are probably still on Swarm.
And the secrets in that is a little better. And there were some examples out there, and I went down that path. Then really above and beyond that, you're looking at a vault, right? You're in HashiCorp, you're in Conjure, or you're using AWS Secrets Vault. Another example I saw was an Amazon service I have to go back and look into, but it's the systems management service, systems manager. Basically it runs an agent on all of your instances and allows you to manage secrets that way. So it's yet another way to and again, I looked at it briefly. I saw some examples and said, wow, that's another way you can manage your secrets. So there are a few different ways to do it. And you could, if you're in Kubernetes, right? The Kubernetes has a way to manage it. It's base 64 encoded. I'm not sure how good that is, obviously. But I think my recommendation, if you're looking at this, is to implement some kind of secret, especially if you're using AWS. You also have to be mindful of how you're deploying these, in which cloud service. So this applies to any cloud service provider, right? You got to look at the services that you're utilizing from that cloud provider, then look at what they have for a vault, what's available, whether it's a third party or another service from that cloud provider, and see how it, or if it integrates with all of your services, right? Like RDS, which Amazon service for secrets does it support, right? Mm-hmm. So you got to look at all your pieces. So that's my advice on secrets. This is just my kind of ghetto hack way, just to basically make sure it's in as few places as possible, minimize the risk that it's going to get into a Git repository. So I do a whole bunch of stuff in this file to set up the system. One thing I am looking at to slim down these images is a multi-stage build, and doing a little better cleanup after myself. What a lot of times when you progress down creating your own container. So that's the other thing, is I had to build my own containers and images and then put them in a registry. If you really want to set yourself up for having this deployment model, when I looked at the Amazon services and examples available, it hinged upon basically using this Docker file, right, in my compose scripts. I create my own container images. I then push those into my own registry.
Into ECR.
ECR, and then all the other Amazon services basically pull from that.
ECR, yeah.
Start down that path, because I went down all kinds of other paths. Start down that path. You need this level of customization if you want this level of control and flexibility as to how you're going to deploy your applications.
So let's talk about why a multi-stage build for a second, because one of the things you found, and if you can show it later, is you needed curl to bring in some other dependencies as part of this build, but curl has vulnerabilities in it that have been there for a long time. But you don't necessarily need curl when you're done.
In the final image.
So a multi-stage build potentially allows you to build your container, get all your dependencies in there, but then the ability to remove curl because you no longer need it is an interesting component.
So this big mess of bash code right here is an attempt to remove the dependencies, right? And there's a lot more here, and I've got some more work to do to make this better. But essentially what this is doing is, so when you install curl, right, through Debian's package manager, it installs all of the dependencies. And you don't want to install the recommended either. And there's a way when you do this, you'll see there's a flag in here to not do the recommended. No install recommends. But that doesn't take care of any of the dependencies. So let's say you install curl, right? And you can see PHP curl there, right? You install curl. Curl has a dependency of I don't know, libcurl or whatever, right? And if you go then and clean up after yourself and remove curl and all of its dependencies in a manual way like I'm showing here, that will potentially remove a library or package that's needed by something else. Because when you installed PHP curl, it goes, oh, the libcurl package dependency is already there, so I don't need to install it. So there's lots of advice and tips, and the next iteration of this will include that. Not only does it make your image smaller, it puts a lot less utilities out there, because you will need like things like git and curl and wget to basically put everything inside of your image.
And it reduces your attack surface.
So then I'm basically customizing configuration files. So I'm using the package manager to install PHP. And these are ways to customize your configurations of those. So you basically either appending this actually creates a new file. And some other examples here using sed will actually modify values. So this is searching for the default value inside of a configuration file and then changing it to something else. So basically you build the base packages, they write configuration files, and you're going to have to dig, like I had to dig through Debian's documentation and packages on the web to say where does it write the configuration files, and then download that package and untar it and look at it and say, okay, what are the default values so I can search for that. Now those could change, which can break your build in the future, but we'll get to that. So basically I'm modifying configuration files on the fly to tweak all of the settings here. You can see I've got some stuff commented out as I was doing some troubleshooting. I also changed the owner of the process as well. If you're sharing file systems depending on how you're sharing those file systems, you might want to change the user. In this particular application, right, the app server and the web server need to access the same file system. So you have to share it. If that's a bind mount on your file system or a volume, right, that needs to have the same user so that they have access to it. There's lots of ways to configure that. But also for simplicity's sake, I wanted the same user on my web server and on my app server running these actual services as well. And there's also weird things with the UID of the user. You can see when I create the user here, I make a specific UID, which allows me to reference that later. Otherwise, it'll just choose one at random and depending on your distro, so it helps you standardize your user things. And then you can see my usage of curl here, right? So I'm actually going to grab the latest MediaWiki version and untarring it. Now, what I thought was cool, and this is a MediaWiki thing, and extensions aren't really all that popular in most MediaWiki instances, I think, but you may have an application that allows you to put add-ons or extensions to it. And so what I'm doing is every time I'm going to the extensions, in this case GitLab repository, downloading the latest version, untarring it, and installing it in my application. Now, they could change something. In fact, I had to back rev one of them because the latest version on their Git repository was for the testing version of MediaWiki and didn't even work with the latest stable version, right? So you got to balance that. But every time I build this container in the image, it's going to pull the latest version of all the extensions, put them in there, and then you should have a process that tests that and see if it breaks. Then you go back and you adjust your config. So you treat it basically ops just like code, right? I mean, this is basically infrastructure as code. So you can see we run quite a few extensions on our MediaWiki instance. And here's where I set the passwords, right? So I am on the fly modifying. So I copy my local settings, right, file over. Then I've set these variables to specific values so that in my script, I'm rewriting those values with the username and password for the database. And again, those values don't exist in my script. I'm reading them from an environment variable, which helps minimize it. Then I'm setting some permissions on some things. And I'm actually not, I had it originally where web server and app server on the same container. Now that they're separate, I'm basically just running PHP FPM as the app server. And there's config in here too, also with logs that's important. You want your logs all going to standard out. So somewhere in here, I'm actually setting a specific configuration file for PHP FPM to write the logs to standard out, and that gives you the Docker log. And when you go to the cloud, I'll make it an easier time of grabbing your logs because they won't be on the file system. They'll be in a place where you can grab them. So that's the app. I do the same thing, similar stuff for the web server. So I'm building 2 containers and images here, and basically doing, similar kind of stuff in here, copying over files. This one's a lot cleaner and easier, as it's just running Nginx. So then I decided to get it running locally first. So this was because going from running on bare metal or everything running in one big instance on a cloud provider, right, as infrastructure as a service, and taking that and trying to do the whole container and the config in AWS or a cloud provider was daunting for me. So I was basically like, I'm going to get it running locally first. That's also where I'll do my development. So you need a specific config for that. So if I look at my Docker Compose dev, I'm spinning up a database locally. Now the nice part here is this username and password set every time I build this image. And so if I need to change my passwords, I can just do that in one place and it'll actually change it across the entire build. Now for this database image that I'm using locally, I'm just pulling the image from Docker Hub. I'm not building my own database image. I wasn't that advantageous. Also in the cloud, I'll probably use RDS and not have a database image. There are some cost things to worry about there. It's a little cheaper, so I'm told, to run it in EC2 or ECS than it is to spin up something in RDS, but it's pros and cons, right?
Yeah, and one of the big challenges we also talked about with containers is, although containers are ephemeral, your data needs to be persistent.
Yes.
Right? And so how do you create that data persistency? Are you running your own database on your own dedicated instance? Are you using something like RDS that's always available?
Yeah. See here, I'm just using a Docker named volume to store my database in locally, right? Because locally, I don't care. I can take the database down. I've had instances where I changed directories that I was building in, and that volume just went away, and I had no database. Right? I had a database, but there was nothing in it, right? So in production, you don't want that to happen. I'll put in a dev environment. I'm like, whatever. I can just restore the database. I run my update scripts. That's how I test it, and it's not a big deal. For some of the other things, how you do volumes is really interesting. So with the app server, I'm in the web server. I'm mounting a local directory on my Linux system to a directory inside the container, and that's a bind mount. And so I'm storing my images there, right? Because basically, in this application, and you may have applications that do this, I'm collecting files or information from the user that then the web server has to serve out. It sounds really scary, but in this case, it's for images, right? When you have a wiki, people have to use the app server to upload the image, and it has to put it in the images directory. Then if they call that page through the web server needs access to those images as well. So you've got this shared volume that you need between containers. Locally, I'm using a bind mount for that. You can go read about all the differences between volumes, and your head will spin like mine did until you start figuring out. And then I'm using a named volume to share the HTML directory, right? Because, and I'm not quite sure if this is absolutely a requirement, but the web server may also need to serve other files that exist in the HTML directory, and the app server needs access to all the PHP files. So there's some, and I'm not entirely sure if the web server just needs access to images or something else. Because basically, if you make a request to the web server for a PHP file, it's going to send that over port 9000 to the app server. So it shouldn't need access to any of the PHP files. So that was just the architecture for this application, which is pretty similar to other applications as well. And there is my Docker image as well that's up on ECS as well. So you can see that. Hopefully that's private, now that I think about that. So
it's public now if it wasn't.
It's public now. Whether it's public or private in the actual settings remains to be seen. So, and that was the last thing that I did in this config, was once I had it up running locally, I changed my image to, that basically tags the image with my repository, right? Then you do Docker Compose push, and it builds the images and shoots them up into your repository. And it'll just do that now automatically with that config in there. Then expose my ports there from my web server. Define your volumes down there. Oh, And so you can see the SSL certs. Again, this isn't a production thing. It's just one way to protect your SSL certs. So rather than risking having my certs get checked into Git, what you do is you create an external volume, which sets certain permissions on the volume. And I named this one SSL certs or whatever, right? Then you have to, there's commands, and there you can find them online, to spin up a dummy container that mounts that volume. Then you Docker CP, Docker copy your certs into that volume. Then you destroy that dummy container. And then you mount that volume into your web server, and it can read your certs. Of course, really all that does is just prevent or at least reduce the risk that I'm going to check my production cert key into a Git repository. Right. So it just kind of hides it. It's not the best way. There's definitely better ways, again, with secrets managers to protect your certs, and you can probably read a few different ways in which applications put the certs into the build process and ultimately end up in production. For me, for this exercise, I thought just creating an external volume was the way to go. How I replicate it in the cloud, I'm still researching the best way to do that. So that was a lot of work to get to that point where I can basically take an open source application that uses a web server, a PHP, and a database, break them out into 3 separate containers, because I had to read a lot of documentation outside of the scope of containers, how I get the web server and the app server on different systems. So this, config you have to do for that. And then so I got it into 3 containers. I got those containers up into the Amazon registry. And that's where I'm at now. That's why this is part 1. Next step will be looking at how I get this configuration into the cloud. Then the next step after that will be either one of 2 things, right? Once you get it up in the cloud, you got to figure out how you get it a static IP address, assign your DNS, get your subnets and all your rules and IAM roles created in AWS in this example, or any cloud provider, right? You've got to define your access control lists, and then figuring out how you're going to do the builds. Code deploy, I think, is the Amazon service that I was looking at today that seems to support a lot of different ways to do that, integrate with Git, so that when I check these files in, which is very common, right? New commits made to Git. Ideally, your testing build process goes, oh, there's new files in Git. Let me pull those. Let me build the entire application. Let me run some automated tests against it. If it fails, send me an email and say, hey, Paul, we built the latest, version of this application. One of your extensions basically 404 the web page or caused an error on the web page, so you need to fix that and won't push it into production. Then I'll fix that problem. It'll do the automated pull, build it in test. If it passes test, automatically push it out to production. That's my goal. That's the end goal.
And the push will be into ECR, and then from ECR, we'll get into the cloud environment.
Correct. Or there's lots of, there's so many different ways to do that, right? You could ideally have a process that pulls from Git, builds the images, pushes them up to ECR into your test repositories, right? Tests the application, deploys it and tests. And then the way it works now in our other app, right, is it just takes those images and just reconfigures basically a compose file and pushes them into production. So it doesn't have to build the software again. And
once they're in ECR, then you can use the scanning tools within ECR to identify vulnerabilities in there.
Yeah, which we're short on time, but I'll show that next time. That once you do get it into ECR, so if you do follow along on this process, and once you get them into ECR, it does show you that you do have vulnerabilities. One of them being libcurl, which I was like, wow, I need to really do a better job of cleaning up after myself inside the containers. So, yeah. That's how you get started, basically pushing some legacy applications into, first Docker, and then start planning your cloud migration strategy. How fancy did that sound? With that, we'll take a short break, come back with our final segment for the show, which will be an interview, so stay tuned.